Okay, so here's a little help with what you asked me about, and I think it was number 12, 17, 18, and 19. So number 12, you actually did just fine with that. It's not quite how I would have set it up, because you put your X right smack dab in the middle of your calculation, but you still calculated for it, and that was fine. So what I did, let me bring that problem up. Darn it, come on now. Of course I can't see it. Oh gosh, my computer froze. So what I did was I knew that the balanced equation was all 1-to-1 ratios. So I think from your numbers, 0.910 grams of silver chloride, and silver chloride is 142.5 grams for 1 mole. I calculated how many moles, and that was 0.0064 moles. And if that's how many moles of silver chloride you've got, that's also how many moles of silver nitrate you've got, because it's all a 1-to-1 balanced equation. Okay, so now you've got 0.0064 moles of silver nitrate. And remember, molarity is moles in 1 liter. We don't have 1 liter, we had 65.7 milliliters. And don't forget that there's 1,000 milliliters in 1 liter. And you end up with the exact same answer this way as the way you did it. So that's perfectly fine. Number 18, oh, there we go. Number 17 and 18, you asked me, does it matter what phase those things are in? And actually, no, it doesn't, and you did just fine on those questions. You did not need to know. There's a thing in there that says, what about chlorine gas, okay? Well, whether chlorine is a solid, liquid, or gas, it is always Cl2. So that won't matter in your calculations. Then you had number 19, and that was probably the more difficult one, ClO3 and KCl. Okay, so you had this mixture here, okay, and the mixture altogether was 0.950 grams, okay, but you don't know how many grams of this and how many grams of that. You don't know. Now what you do know is that you end up with some KCl, and we do know that that's 0.85 grams. We know that the only other product is oxygen. So if this mixture is what we started with, the mass of the reactants must equal the mass of the products. And so, oops, I think I have a wrong number in there. To produce, this is supposed to be 0.00, I think. Did you have that information? No, yours was 0.7, okay, 0.710. Okay, there we go. Okay, and so that means the remaining mass was 0.240 grams of oxygen, right? Okay, now we need to balance this. So we've got a 2 here and a 3 there. Whoops, 2 there and a 3 there. Okay. So all of the oxygen came from the KClO3. So even though it's a mixture, we don't really need to worry about that, because really the only thing that really and truly reacted was this, and it became this and this. Okay, so this is you know, you've got the stuff that reacted, but you also have what you started with. So this is, some of it is still from the mixture, and some of it is produced from the KClO3. Okay, so you've got 0.240 grams of oxygen, and there's 32 grams in 1 mole of oxygen, and there's 3 moles of oxygen that react with 2 moles of KClO3, and 1 mole of KClO3 is 122 grams. Okay, so you get some number of grams there, whatever you get, okay, from that answer, divided by the mixture number, multiplied by 100, and then you get your percentage. All right, I hope that helps, and I certainly want to just, you know, ask you and tell you that you can always have a Zoom lesson with me. I don't know if Thursday at 9 o'clock is going to work out too well with people, but I did have a few people ask. But thank you for your feedback on that, because if nobody responds back, then I might need to rethink that. So anyway, thank you for those questions, and you're going to see some problems like that on the test. Okay, have a great week.